In this video, we'll talk about a very interesting phenomenon in inductor. Uh, if we suddenly close the inductor, I mean, like if the inductor is interrupted suddenly, then what will happen? See, observe, like what I'm trying to tell you is, suppose you have a DC power supply, and for this DC power supply you are giving a switch, and then you are giving a diode. There is no issue in this point. And then you are using a inductor, and then you are using a resistor. So what is actually going to happen is that you have to observe. Now understand, try to understand carefully. So this is inductor and this is the resistor. Now we have already seen some case where this is, I am representing time, that time in seconds. Now at this instant of time I am closing the switch. So when, and I am assuming this is the current in I in amperes. So till this point there is no current, okay, because the switch is open, so there is no current. Now all of a sudden I close the switch. When I close the switch, so this inductor will try to allow the current slowly, and it will reach to certain position where the current will be limited by this value of R, say that is V by R. So this amount of current is there in this point, I mean minus the drop of the diode, if you consider the drop of the diode. Now, so this current is going on, so the inductor is getting energized, and the current is going on in this fashion. Suddenly what we do is we open the switch. So suddenly what I'm doing is open the switch. Okay, when we open the switch, so according to the property of this inductor will not suddenly change the current to zero. That means the inductor current will not go zero suddenly. This will never happen. So what will happen is inductor current will try to go in a however it is increasing, the same way it will try to decrease. So inductor current will never go to zero. So then if I open this switch, and switch opening in the sense, the resistance is how much? Resistance is approximately infinity. Now the voltage that will develop across this is I into R. I mean the voltage across the switch that is developed into I into R across the switch. So now the current is still there. That current is how much? Vs by R. Current is still going, and the value of resistance between these two terminals is infinity. So then it will become totally, the voltage is infinite. That means what? A infinite amount of voltage will appear across the switch, and the switch will blast. So let us take a case where it is actually happening. Let us take a case. Instead of a switch, you replace with 10 ohm resistance. So I am assuming the resistance here is 10 ohms, and the voltage is 10 volts. The current is 1 ampere. So now suddenly, instead of what you do, instead of opening the switch, you replace this one with a 10 ohm resistance. Then the voltage will appear across is exactly 10 volts. Instead of that, if you try to replace this one with 100 ohm resistance, and the voltage that appear across this is 100 volts, like this, that means instantaneously you can create an enormous amount of energy, enormous amount of voltage. So that voltage is really critical for these devices, and the breakdown strength of these devices will hit, and this device will get failure. And hence what we do, so because generally here we use power electronic switches, and if that is the case, the switch will blown out. So for this, generally what we do is we will add a diode in parallel with this phenomenon. This diode is called freewheeling diode. What is meant by freewheeling? So what is actually happening here is, so let again, if you see our initial design, so what is actually we have discussed. Now when I close the switch, the current starts flowing through the inductor, and this will slowly rise, and it will raise to one point. When I suddenly open this switch, so whatever the energy that is there in the inductor, the polarity will change. It will try to still conduct in the same path. So instead of we sending the current to this one, what we do, we'll send the current through this diode and then back to inductor here itself. That means we are flowing the current in this inside the path of this itself. This type of operation. So in this one, what will happen? The inductor will try to slowly, the current will come, and again the current will flow in this path. So the inductor will try to slowly and commits to zero. It will try to discharge completely path. So this type of operation is called freewheeling operation. So this type of diode that we use here is called the freewheeling diode. This is how we can extract the energy that is there in the inductor.